Hello students, welcome to the video lecture titled The Study of Chemical Reactions, and I introduced myself as Dr. Bhaswati Bhattacharya, Associate Professor, Department of Chemistry, Government Girls General Degree College, and this topic of my present lecture is included in your CBCS criteria under same 2 syllabus. Now, you can see the detailed syllabus, and I will discuss in details in our next slides. The basic tools to study a reaction mechanism, we have to know the terms listed here. That is equilibrium constant, free energy change, enthalpy, entropy, bond dissociation energy, kinetics, and activation energy. Now, if we consider a chemical reaction, a molecule may be converted to another molecule through a series of bond breaking and making. A new molecule generated, we know it is called product, and that of the starting molecule known as reactant. A detailed step-by-step study by which a reactant is converted to product is known as reaction mechanism. The whole journey from reactant to product can be achieved by proper assessment of the thermodynamic, that is energy related, and kinetic requirements, that is related to rate of a reaction. So we will concentrate mainly on the parts such as thermodynamic requirement of reactions, kinetic requirements of reactions, and finally investigation of reaction course. To know details, we have to know some notations. For example, heat. Heat is the most common form of energy introduced into or released from chemical reactions. But sometimes light, electrical current, and sound may also be involved. The energy absorbed or released in these reactions is referred to as bond dissociation energy. If the bond dissociation energy is introduced from the surroundings in the form of heat, the transformation is said to be endothermic. If heat passes from the system to the surroundings, the transformation is termed as exothermic. In details, here is an example, the combustion of methane. Here all 4 plus 2, 6 bonds of the reactant molecules are broken, and 6 new bonds, 4 for carbon dioxide and 2 for water, are formed in the product molecules. The sum of the product bond strength is greater than the sum of reactant bond strength if we calculate. Consequently, the products are energetically, or you may call thermodynamically, more stable than the reactants, and energy is released in the form of heat. Such reactions are called exothermic reactions. Exothermic reactions are as proceeding from higher energy state, that is less stable reactant, to the lower energy state, that is more stable product state, as you have seen in the diagram. Now, reactions in which the products are higher energy state than the reactant require an energy input to occur and are called endothermic. One of the example is photosynthesis. Here carbon dioxide and water in presence of sunlight form glucose molecule and oxygen. It is an example of endothermic reaction. Now, what is thermodynamics? The science that investigates the passage of energy from one system to another and the transformation of energy from one form to another is called thermodynamics. To know thermodynamics better, we have to know some definition and some terms. Here one of them is enthalpy. In classical thermodynamics, it is a statistical science in which observations are made on macroscopic samples. Heat energy or heat content is designated as enthalpy and symbolized as H, capital H. The enthalpy change in a physical or chemical transformation is written as delta H, which is defined as del H product minus H reactant. Because of this formalism, which holds for other thermodynamic functions as well, exothermic reactions have a negative delta H and endothermic reactions have a positive delta H. You must remember that negative delta H means exothermic reactions, and for endothermic reactions it must have positive delta H. Now we can calculate bond energies like this way. Total bond energies of reactants compared with the bond energies of the products determines the enthalpy change of the reaction. You have seen from the diagram. Thus, if the products have a greater total bond energy than the reactants, the reaction will be exothermic, and the opposite is true for an endothermic reaction. The following diagram illustrates this relationship for the combustion of methane. Bond energies may be used for rough calculation of enthalpies of reaction. To do so, the total bond energies of the reactant, here the total bond energies of the reactant molecules must be subtracted from the total bond energies of the product molecules, and the resulting sign must be changed. You can see total product bond energies as depicted here and minus some of the reactant bond energies. It is designated as delta H of the reactions, and if we calculate it, we can obtain the delta H for this reaction. As it is negative, so the reaction is exothermic in nature. Thank you. This is end of part 1.